Hey everybody, we are taking a look at the three dogs here pulling this chew toy. The way we're visualizing this is kind of the way a drone or a bird would be looking at this from the top down. So if there was a force of gravity we'd have to pay attention to, it's kind of going into the screen. But we don't have to. We're told that the force of gravity is negligible. So I'm going to start every single problem I do in this unit with force with a picture, and this picture is going to show me the forces that are pushing or pulling on this ring. And in this case I've got the dachshund pulling down and to the left, so F sub D. I've got the golden retriever pulling down and to the right, I'll say F sub G. And then I've got the bulldog pulling straight up, F sub B. Now that's a wonderful force diagram, and that's exactly what I need when I'm thinking about the forces that are pushing or pulling on this. But what I'm going to draw is something called a component diagram. When I'm actually calculating the forces, I'm going to need to know what is horizontal and what is vertical. So, for example, the force of the bulldog, totally good. I'll be able to keep that in my component diagram and just label that F sub D. But the fact that the dachshund is pulling down and to the left, I'm going to draw those as two separate components on here. And I'm going to say this is FDY, and that this over here is FDX. I'll do the same thing for the golden retriever, who's pulling down, so FGY, and pulling to the right, FGX. That's going to be very helpful when I'm thinking about the math that I have to do. Let me zoom out of it. Because I'm trying to figure out how much force the golden retriever is pulling with. And the way I'm going to think about that is figuring out how much the golden retriever is pulling in the X and how much the golden retriever is pulling in the Y direction. So I can start off with the X direction. And I'll do that by saying the sum of the forces in the X direction equals 0. And using the convention that everything to the right is positive, everything to the left is negative, I can say, okay, that means that FGX minus FDX equals 0, or FGX equals FDX. And you might have said, that makes a ton of sense, because this ring is not accelerating, so we have to have balanced forces here. That's why this is happening, because the golden retriever is pulling as much to the right as the dachshund is pulling to the left. To figure out how much the dachshund is pulling to the left, I'm going to revisit the fact that the dachshund is pulling at 25 newtons at 200 degrees. Now, on a unit circle, 200 degrees would be this blue blue angle. I'm drawing right here. 200 degrees. It's probably more helpful to pay attention to this green angle right here and call this 20 degrees. Because I'm about to do some trigonometry to figure out how much the dachshund is pulling down and how much the dachshund is pulling to the left. And I'm going to do that by making a triangle, or at least something that looks like a triangle. I'm going to go right here and say, all right, how much is this down? And how much is this to the left? Trigonometry can help me figure that out. That over here, this must be 25 multiplied by the cosine of 20 degrees. You can pause the video and do a little math to see that the cosine of theta must equal adjacent over the hypotenuse. And that means that the hypotenuse multiplied by the cosine of theta equals the adjacent side. And pause the video until you feel good about the fact that this left force must be 25 multiplied by the cosine of 20 degrees. Then I can revisit my math and put that right in for the force of the dachshund in the x, and realize the golden retriever in the x must equal the same thing. 25 newtons multiplied by the cosine of 20 degrees. For a grand total of 23.5 newtons. That's how much the golden retriever must be pulling to the right. I can do similar thinking for the y direction. Sum of the forces in the y direction equals 0. So the force of the bulldog minus the force of the dachshund in the y direction minus the force of the golden retriever will equal 0. Or the 80 newtons for the bulldog minus the force of the dachshund in the y direction. Coming on over here, this whole vector, it must be 25 times the sine of 20 degrees. It's got to be the same thing over here. 25 times the sine of 20 degrees is 8.6 newtons. Minus the force of the golden retriever in the y direction equals 0. Or the golden retriever in the y direction has to be 71.4 newtons. And together, that really tells a story about what the golden retriever is doing. The golden retriever on this chew ring, I'll put that in red, the golden retriever is pulling to the right at 23.5 newtons and down at 71.4 newtons for a total force this way. Now that total force, that's what I'm trying to find out in this problem. I need to know how big that is. That would just be the hypotenuse of a triangle that has sides 23.5 and 71.4. That gives me a total force of 75.2 newtons. That's the magnitude of the force. The direction, I would need this full direction that I'm about to draw. 0 degrees, past 90, past 180, past 270, all the way to here. That is going to be my angle. Now, there's different methods you could use to get there. Some people will solve for this blue angle I'm drawing here, and then add 270 to that blue angle to get the full answer. And some people will take this green one I can draw here and then subtract 360 from that. Either way, our answer should be down and to the right because the golden retriever is pulling that way. So it has to be between 270 degrees and 360 degrees. I can also realize that because we're moving more the golden retriever is pulling more down than the golden retriever is pulling to the right, my answer has to be smaller than 315 degrees. So my answer is going to lie somewhere in here. And I can figure that out. I'll find this blue angle right here. The side of this is 23.5 newtons. So I can do some inverse tangent of the opposite side, 23.5 over 71.4, and that equals, I'll call this phi, and That's 18.2. But of course, I need to add 270 to that, because that would be 270 plus the little blue one equals the full angle we need. Or that would be 288 degrees. And anything right around there will be excellent and well done and acceptable, because there's different places where you can round that. But the idea is we got an answer that makes sense. The golden retriever should be pulling at a good amount of force, 75.2 newtons, because they have 23 newtons of pull to the right and 71 newtons down, at an angle that's also down to the right, but more down. And we got those values by drawing a good force diagram and a component diagram to help us think about this example. So make sure you feel good about this one. Thanks for watching.